electric potential and electric potential energy and electric potential difference. Three things are there, and force and energy are two important concepts around which then most of the physics revolves around. So in fact, physics concepts, and here we need to understand potential energy before understanding potential or potential difference. So at the beginning of the videos we discussed that electric field is nothing but the force acting on a unit positive charge. In the same fashion, electric potential energy is the work done to move a charge, because in order to move a mass in the gravitational field, you have to do some work. That work on the mass is stored. So that stored thing is called energy. In the same fashion, here when you move a charge in the electric field, because electric field is produced by one charge, so because of that charge, in order to move another charge, you have to exert some force. That force may be positive or negative, and that energy will be stored in the charge. That is called potential energy. And that potential energy on 1 coulomb charge plus 1 coulomb charge is called potential. So here let me just explain this using a small thing. So there is a charge q at this point. This is a point charge, and surrounding this point charge there will be a field. In order to move any charge in this region, you have to do some work. Now first we are going to define the difference and then the absolute value, and then we'll find out that absolute value. Suppose consider 2 points here and here, A and B. What is potential of A? I am talking about electric potential. So electric potential of A with respect to B, we call this VAB. Electric potential of A with respect to B, which is usually VA minus VB. You know what is VA minus VB? I have 500 rupees, the other person has say 400 rupees. My value with respect to his value, I mean how much I am more, it is my value minus his value, which is 500 minus 400, which is 100 positive. That means I am at a higher position. In the same way, VA minus VB is VA minus VB. In this case, if it is positive, potential of A is higher than the potential of B. Like that we can write. So how do we define this? It is the work done to move plus 1 coulomb charge, that unit positive charge, from A to B by the electric force. This is the most important thing. Work done to move a unit positive charge from A to B by the electric force is called electric potential difference. So electric potential difference, VAB, relative potential difference, because value of A with respect to B, potential of A with respect to B is the work done to move a unit positive charge from A to B by whom? The electric field. So then you can write like, what is work done? Work done is force into displacement. Here force, you need to move who? Plus 1 coulomb charge. So it is the force into displacement from where to where? A to B. Force into displacement. So who you are going to move? Plus 1 coulomb charge. It is a force on plus 1 coulomb charge into displacement from where to where? A to B. Force on 1 coulomb charge by the electric this point charge is called electric field. Force on 1 coulomb charge is nothing but electric field into displacement from A to B, which is called VAB. Okay, so VAB is equal to E into displacement from A to B. Let us say work done by the electric force from A to B is actually equal to work done by the external force from B to A in a negative sense. So you can write it as, it is E, and displacement from A to B is displacement from B to A with a negative sign, because A to B is positive means B to A is negative. So it is VE into displacement from B to A. This is called what? VAB or potential difference. I'm going to just generalize this even more. VAB is potential difference between one point to the other point is equal to minus of the electric field into displacement from, not from this point to this point, from the other point to this point, which is dx. So dV, potential difference, is equal to negative of the electric field into displacement from the final point to the initial point, not from initial point to the final point. So then from this we are going to have another important thing. E is equal to minus of this minus sign coming to this side, dV by dx. So this is called electric field. The other definition we have got. So electric field is the region around the charge wherein its influence is felt. Definition number 1. Definition number 2 is force on unit positive charge, and the definition number 3 is negative of dV by dx. This we call, dV means change in potential, dx means distance. Change in potential with respect to distance is called gradient. I hope last year we studied elasticity. Even in elasticity we spoke about this thing, exactly saying viscosity, right? In that viscosity, you just remember when you put a drop of honey on your palm, when you just slightly incline it, then you will find that the honey is rolling down. So the layer of the liquid in contact with the surface is at rest, the top layer is moving faster. So the difference in velocity of layers is called velocity gradient with respect to distance. The same way here, potential gradient means difference in potential for every 1 meter. Suppose this wall has 50 degrees Celsius, that wall has 0 degrees Celsius. The distance between the walls, let's say 5 meter. In that 5 meter, temperature changes from 50 degrees Celsius to 0 degrees Celsius. So this 50 degrees Celsius of difference for 5 meters, then for 1 meter it is 10 degrees Celsius. This 10 degrees Celsius per meter is called temperature gradient. That was the one in viscosity we discussed about velocity gradient. Here it is called potential gradient. So electric field is negative of the potential gradient, and in this light you can write the unit of electric field is unit of potential difference by distance. The distance is measured in meter, and this potential difference, you know, if you purchase any battery or cell, the potential difference is mentioned in that cell in volt. So here the potential difference is measured in volt, so it is volt per meter. So the unit of electric field is volt per meter, or the other definition which we had, electric field is force per unit charge. Q coulomb charge, F Newton. 1 coulomb charge, F Newton by Q coulomb, that is Newton per coulomb. Now that we have 2 units for electric field, which we will be studying one more unit for electric field. So this one is volt per meter or Newton per coulomb. So far we have got 3 definitions of electric field. We will be studying the 4th definition also. We will study in the couple of videos after this one. So we have finally arrived at electric field is the negative of the potential gradient. From this I am going to calculate electric potential at a point and the potential difference between 2 points. In line with whatever we have discussed, we are going to derive an expression for the electric potential due to a point charge. Okay, so electric potential and potential difference, we'll come back to the difference. So there is a point charge Q. From the point charge at a distance r1, there is a point 1. At a distance r2, there is a point 2. Then what is potential of 1 with respect to 2? Based on the definition we just did now, V12 is work done by the electric field to move 1 coulomb charge from 1 to 2, which is negative of the work done by an external force from 2 to 1. That's why we said force by the electric field is E, means force by the external force, external field is minus E into the distance from 2 to 1. So it is dx2 to 1. From this, the total potential difference is, the thing is, at every point electric field changes, because expression for the electric field E at a distance x is 1 by 4 pi epsilon naught into this charge q by x square. So when the x changes, field changes. Field is nothing but force on 1 coulomb charge. Hence force changes. Because the force changes, work done changes. So how you have to do it? It is not a simple like electric field into displacement, because at each displacement electric field is keeping on changing. So what you have to do is, this total distance you have to split it into small distances dx. Within the small distance dx, work done is E dot dx. Then first E dot dx, E dot dx, E dot dx, E dot dx. If you sum up all that, you will get the total potential difference V12. That is why the total potential difference V12 is sum of all E dot dx from point 2 to 1. Difference from 1 to 2 is sum of E dot dx from point 2 to 1 with a negative sign. This summation is done by the integration tool. We are employing the integration here. E dot dx. From where to where you are moving? You are moving from a distance R2 to distance R1. So it is R2 to R1. Then minus of integral R2 to R1 you are moving. So since as you are moving, your distance is changing by dx, 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 right? So you need to establish a typical relationship. At a distance x, if you move a distance by dx, then the work done is, at a distance x, electric field is 1 by 4 pi epsilon naught into q by x square into small distance dx, that is called E dot dx. That's what we are going to do here. So it is at a distance x, q by 4 pi epsilon naught x square into dx from R2 to R1. Then the potential difference dV or V12 is minus 1 by 4 pi epsilon naught into q into integral, I will write q here, integral dx by x square, but that x when goes up it becomes x power minus 2 dx. From where to where? R2 to R1. So if you move from R2 to R1, you will find the difference. But suppose imagine there is a scale. If you move from 4th centimeter, here is where the 0 mark, 4th centimeter to 9th centimeter, the difference is 5 centimeter. But you will only know how much distance. Suppose this is 0.2, this is 0.1. When you move from 0.2 to 1, you know that you have moved 5 centimeter. But what this 0.1 means, you don't know. But the 0.1 means 9 centimeter. How do you know this is 9 centimeter? If you move from 0 to this 0.1, you know that you have moved 9 centimeter. If you move from 0 to this point 2, you know that you moved 4 centimeter. Then obviously the difference is 9 centimeter minus 4 centimeter. In the same way, if you want to find out the actual value here, you have to move from 0. Here 0 means work done is 0. Where the work done is 0? At infinity, electric field is 0. Because electric field is 0, to move any here plus 1 coulomb charge at infinity, work done is 0 and hence potential is 0 at infinity. So you are going to move from infinity to a particular distance r, you know electric potential at a point r. Suppose this is the charge q, you would like to find what is the potential here at this point at a distance r. Then you have to move charge from infinity to this point. So you set R2 at infinity, R1 at R, you know the electric potential at R. So R2 is at infinity, then this formula we are setting R2 at infinity, R1 at a distance R. So minus q by 4 pi epsilon naught x power minus 2 dx is x power minus 2 plus 1 divided by minus 2 plus 1 from where to where? From infinity to r. Then minus q by 4 pi epsilon naught into minus 2 plus 1 is minus, then 1 x power minus 2 plus 1 is x power minus 1, x power minus 1 is 1 by x, then infinity to r. So upper limit minus lower limit. So upper limit minus lower limit is then sorry, there is a negative sign, right? So this negative sign, here is one minus, this minus into minus becomes plus, so it is 1 by 4 pi epsilon naught 1 by r minus 1 by infinity, so 1 by r minus 1 by infinity, 1 by infinity becomes 0, so expression for the potential at a point r is equal to 1 by 4 pi epsilon naught into q by r. This is the expression for electric potential at a point P at a distance r from the charge Q.